Hi, Autumn. So I am gonna start with the top of that page that you sent me, which is number 6 through number 9. Um, I think that what this part is trying to teach you is the relationship between the frequency of a wave and the wavelength of a wave, and then how those relate to energy. So it's really conceptual. Um, so I'll talk through what each of those things means, and then we can work on those problems. So the frequency. Actually, let me back up a second. So a wave, if I remember right, is from, let's say it would be, let's start right here. So the middle line, right in the middle, and then it would be one full wave until you get back to the middle again. So it would have one peak and one valley, and then you'd get back to the middle again, and that's one wave. Um, so frequency is the amount of waves that you have in a given time period or distance. So if we're looking, let's say that this was the distance that the waves had to travel, we could see that the shorter waves, you're going to have more of those in that given amount of time or distance. Um, so here you'd have like 3 or 4 waves within there. Um, but if we took that same distance over here, you may not even have a full wave. Okay, so this is more frequent. Okay, it happens more often. You have more waves in a given amount of time. This is less frequent. Okay, so this side of the spectrum has a high frequency. This side of the spectrum has a low frequency or a lower frequency. Um, the next thing is the wavelength. So if you have a high frequency, the space in between the tops of the waves and the bottoms of the waves is really minimal, right? Like you don't have a large length in between those. Okay, so that's what they're talking about with the wavelength is how long, literally how long length is the wave. Okay, so these ones have a really short wavelength. They're super frequent, short wavelength. These ones have a longer wavelength. They take up a longer amount of space. Okay. And I think your first question asks you to rank the parts of the electromagnetic spectrum from the lowest frequency to the highest frequency. So you must have something, I don't know, maybe like this that's labeled A through G. And so you're going to label it from the lowest frequency. So basically, things over here have a low frequency, things over here have a high frequency. So you'll label it that way. Number two, or sorry, 7, rank the parts of the electromagnetic spectrum from the shortest wavelength to the longest wavelength. Okay, so again, we just talked about that. So you should be able to do that part. Short wavelengths, not very long on this end. These have the longer wavelengths. And then it asks you, what is the relationship between frequency and wavelength? I'm not going to tell you this one, but I'll help you with what the question is asking. So, a direct relationship means that if one increases, so if one increases, then the other increases. So, it's wondering if you increase the wavelength, are you increasing the frequency? That would be a direct relationship. An inverse relationship would be if you increase the wavelength, you are decreasing the frequency. So if you make the wave longer, is the frequency or the amount of times that a wave passes through a certain area, is that decreasing? Okay. And then I just have a few seconds left, so I'll try and wrap this part up. So relationship between frequency and energy. This arrow up at the top shows you increasing energy. So this side of the spectrum is going to have a higher energy, okay, high frequency, high energy. I think about like um, if you're running, right? You've got lots of steps really fast.